So I threw in an extra example with the partial fractions. Now, if you're like, I'm done with the partial fractions, I don't want to do another problem, that's fine. This is all optional anyway. But if you wanted to do a little more math today, you know how sometimes it all makes sense in class and then you go to do the homework and you get some crazy problem and it looks like you've never seen that before. So I tried to find one of those that I thought looked like a crazy problem from the homework, and I thought I would show you how I would do this problem. So, okay, and it looks okay to start with, except we have a factor of 2 in the denominator, and what are we going to do with that 2? And the way I chose to do it, and you could do it differently. First of all, what I looked for was, would 2 go into all of those coefficients in the numerator? That would have been so much easier. But it doesn't go evenly into 127. So I said, well, okay, I'm going to leave the 2 down in the denominator. And then here's what I decided to do with it. So I said, well, I've got a factor of x squared, right? So that's a repeated linear factor. Looks a little different. I decided to keep the 2 with it. So I kept it 2x here, and then I made this one 2x squared. Now, you wouldn't have to do it that way. That's just the way I chose to do it. So I kept the 2 with the first 2 denominators. And you'll see what happens as I go through this problem. Okay, both of those have linear factors, so that means we're going to have an a up here and a b up here. So you've got a factor of x, then you've got the factor x repeated, x squared. All right, then I went to the 3x plus 2, right? So I didn't put a 2, a factor of 2. I just left it 3x plus 2. That is also a linear factor, by the way, so that's just going to give us a c up here. And then finally, it's a 3x plus 2 squared. So I guess what I'm trying to point out, well, let me finish this. That's also the linear factor repeated, so that's just going to be a d up there. But I guess I'm trying to point out is that constant of 2 kind of is, well, where do you want that 2 to be? And you're going to see what happens as we go through this problem. Okay, so here we go, some crazy numbers, right? All right, we're going to have a times, I've got the 2, I've got 1x, I'm going to need another x, and I'm going to need the 3x plus 2 squared. Why am I getting all these dots all of a sudden? Okay. The next one, I've got the 2x squared, but it's going to be b times the 3x plus 2 squared. And then I'm going to have the c. I'm going to have to multiply that by the 2x squared. How do I want to write that? 2x squared, because I didn't include the 2, right? And I'm going to also need the 3x plus 2 factor in there. And then finally at the end, I'm going to need a d times 2x squared. So you're still trying to get those common denominators. It's just a little more complicated. And we also have that 2 in there that's a constant and it's a factor, but that's how I chose how to handle it. Okay, now let's see what happens. So we've got ax times, I'm going to square that binomial, 9x squared plus 12x plus 4. We're going to get good at that. B times 9x squared plus 12x plus 4. So you can already see, okay, I'm repeating some stuff here. I'll just leave my little dots there. Plus, now it's going to be 2cx squared times 3x plus 2. So I still have some distributing to do. And then finally, my last term is going to be 2dx squared. I try to keep the numeric coefficient in front, then the a, b, c, d next, and then the x term. Okay, so that just helps me keep things straight. All right, so finishing our multiplying here, we're going to have 9a x cubed plus 12a x squared plus 4ax plus 9bx squared plus 12bx, I don't know if this is all going to fit, plus 4b plus, I'm going to try to make it fit, 6cx cubed plus 4cx squared plus 2dx squared. Now you know those exponents are important because when we go to do the matching up thing, it makes a difference which coefficients are going together. Okay, so I think I've got everything straightened away there. All right, now we're going to start playing the matchup game here. So my 54 has to equal the x cubed term. So 9a plus, I think there's another one, 6c. Okay, let's switch colors. And we'll say the 127. Kind of a 127 that's messing things up. So these are the x squared terms. 12a plus 9b plus 4c plus 2d. So that's kind of a long one there. And what else do we have? An 80, right? So there's the 80. 80 equals, now these are the x terms. So 4a plus 12b. And then finally, we've got the 16 is equal to 4b. Okay, so good news here. That last equation in purple, that's going to get us our b. So we'll divide both sides by 4, 4 equals b. There, that one's done. Now we're going to go back to the blue equation, which has a and b, but since we know what b is, we can figure that out. So 80 equals 4a plus 12 times 4. That's going to be 48, and you subtract it, it's going to be 32 over here. And then I kind of try to do the math a little quicker so these videos won't be quite so long, but I stop the tape and figure it out. A equals 8. Okay, so that looks good. Now that we know A, let's see if we can get C then. So let's go to the first equation. 54 is going to equal 9 times 8 plus the 6C. Okay, so that's 72. If you subtract that, you're going to get a negative 18 equals 6C, or C equals negative 3. Okay, now we can go to the green equation and figure out what D is. So we have 127, 12 times 8 plus 9 times B was 4, plus 4 times negative 3, plus the 2D. Okay, so 127, that's going to be 96, 36, minus 12, plus 2D. What is all that? 24 and 96 is like 120. So it's like 127 equals 120 plus 2D. Okay, now here's where, the sadness comes in, I guess. 7 equals 2D. Well, that's not going to divide evenly. We're not going to go with a decimal here. We're going to leave it 7 over 2 equals D, and I'll show you how we'll handle that in the end with our expression. Okay, so if you remember, we found A, B, C, and D, they were all just linear constants for the numerators, okay? So we can just write it now, our decomposition, and it's going to say this. So my A was 8, right? Now, what I had chosen for my denominator, look at all these little extra marks here. Get rid of those. Okay, sorry. 8 over 2x. So you have to go back to the beginning, how we set it up. But I'm going to fix that in a little bit. Now, what was B? B was 4. over 2x squared. And C was negative 3 over 3x plus 2. And then the D. Now, for right this minute, I'm going to write 7/2. I'll fix this all in a second. Over 3x plus 2 squared. So if you were just following along with how we were doing these partial fractions, you might say, oh, okay, my answer would look something. I'd put I found A, B, C, and D. I'd put them in over those denominators that I had set up, and that's what it looks like. But we're going to clean this up a little bit. First of all, we're going to reduce anything that can reduce. So 4 over x plus 2 over x squared. So you might say, okay, well, we had the 2 in there, but now we took it out. Would it have been easier another way? I don't know. This is how I did it. 3 over 3x plus 2. And then finally that 7/2, I'm going to leave the 7 in the numerator. So you think of it like 7/2 times 1 over 3x plus 2 squared. I'm going to leave the 7 in the numerator, and then that 2 is going to come down here. So I just wanted to do that problem because it had a few extra little things that we hadn't shown before, but that's the answer. So, okay.